In this section, we are going to talk about the sum of independent random variables. So naturally enough, we're going to start off with the fact that x and y are independent, continuous random variables. And having PDF, fx, and f sub y. Those are the PDFs. So, what is a cumulative distribution? The cumulative distribution function of the sum x plus y is going to be given by capital F sub x plus y of a. And this is going to be the probability. Now, as long as this is big F, I don't care what that says. The probability of that is less than or equal to a, which is the double integral of fx of our x times fy of y dx. And this is over x plus y is less than or equal to a, which means solving for x is that x is less than a minus y. Just subtract y from both sides. So this is equal to the double integral. I'm going to do dx first. So I can factor out this fy of a times fx of a dx times dy. And dy goes from negative infinity to infinity, but x goes from negative infinity up to a minus y. Up to a minus y. And this is equal to, well, this portion, so let's write down everything else. The integral from negative infinity to infinity of fy of a, well, that's what's in the big box that I just drew. From negative infinity, x goes from negative infinity to a minus y, and we're adding up the PDF. That's the cumulative distribution. That's big F of a minus y dy. Okay, so now on this last line, I'll do it on the top, but on this last line, we're going to take the derivative of both sides. Remember, when I say the last line, I really mean that this equals this. I'm going to take the derivative of both of those sides. And let's do that right here. Let's write down the statement that I just said. F sub x plus y, I didn't mean to put the brackets, but I can. This is equal to the integral, just a little space I need. This is equal to the integral from negative infinity to infinity of f sub y of a times big F sub x of a minus y dy. I'm going to take the derivative of both sides with respect to a. I'm going to take the derivative of both of these sides with respect to a. Okay. Well, the derivative of big F of x plus y of a is just going to be little f sub x plus y of a. And on the other side, since fx and fy are continuous, I can put the derivative inside the integral. That is, I can take the derivative of fy of a times fx of a minus y and integrate that with respect to x. And I have been writing one little error. I'm sorry. This should still be y. This should still be y. Okay, so f sub x plus y of a is equal to the integral of something times dy. So we have the derivative of that times that. This is not a function of a, it's a constant. Remember, the derivative of 7 times a squared is 7 times the derivative of a squared. This is 7 times the derivative with respect to a of a squared is 2a, 14a. Of course, you've just been taught to multiply. So that is f sub y of y is a constant times the derivative of this. The derivative of f sub x, big F sub x of anything, is little f sub x of the anything times the derivative of that, which is 1. And with respect to a, the derivative of a minus y is a. Sorry, is 1. And multiplying by 1, well, don't bother. Okay. And one last thing, the limits for y go from negative infinity to infinity. So here is the PDF of f sub x plus y. It's the PDF of the sum of independent random variables. Okay. So let's remember this formula. Let me put it on the bottom. Okay. That is the PDF of the sum of two random variables. But what if these random variables are independent? Well, yes, they're independent. What if they're uniformly continuous as well on, say, the interval 0, 1? So, if x and y are independent, uniformly distributed random variables on 0, 1, they're uniformly distributed on 0, 1. If that's true, we want to calculate the PDF of their sum. That's what we're doing in this section, talking about sums. Well, it turns out that the PDF of x at a is the same as the PDF for the y function at a, for the y random variable at a. They're both equal to 1 over b minus a, which is 1. 1 over 1 is 1. But this is only if a is between 0 and 1. And it's 0 otherwise. It's 0 otherwise. Go between 0 and 1. So the height, call it K for a moment. If it's uniform, that means it's the same height all the way across. Thing is, the total area has to be 1. So the area is, on one hand, it's the base, which is 1, times the height, 0 to K is K. On one hand, it's K. 1 times K is K. But on the other hand, the area is 1. Oh, K is 1. K is 1. That is why I have 1. The PDF is always 1 over the length of the base. If we go from here to here, if this base was L, well then the height is going to have to be 1 over L, because that would make the area be 1. The base is L times the height is 1 over L. You get 1, which is what you want. It's 1 over B minus A. If I said L was B minus A, that's their base, times the height is 1 over B minus A. Sure, we get 1. That is, the height is always going to be the reciprocal of the base. If the base is 7/3, the height should be the reciprocal. You get 1. Even if you don't know what 7 times 3 was, maybe they were less friendly numbers. It's certainly the same as 3 times 7. When you divide the same quantities, you get 1. Okay. Let's get rid of this silliness here. Okay. Now, okay. We know that x is between 0 and 1. Whether we include the endpoints or not won't really matter. Y is between 0 and 1. So x plus y, just literally adding, 0 plus 0 is 0. X plus y is x plus y. And 1 plus 1 is 2. That is, x plus y goes between 1 and 2. I want to break between 0 and 2. 0 and 2. I want to break it up into 2 pieces. From 0 to 1, and then from 1 to 2. Alright, so now, for a between 0 and 1, we have that f sub x plus y of a is equal to, now, both of these are 1. Fx is always 1. Fx of anything is 1, as long as the anything is between 0 and 1. Okay, so, well, 1 times dy is just dy. And y goes from 0 to a. Y goes from 0 to a. Let me just write this a little bit smaller so I can have more room. Integral from 0 to a of dy. The integral of dy is just y. From 0 to a. You plug a in, you get a. You plug 0 in, you get 0. Taking away 0 doesn't do anything. A minus 0 is just a. So, we know, we just learned something. If a is between 0 and 1, their PDF of the sum of those two random variables, x and y, is a. Now, what if a, so we dealt with 0 to 1, what if a is between 1 and 2? Okay. So, we take away 1 from all sides, and we get that a minus 1 in the middle is between 0 and 1. Okay. So, f sub x plus y of a, this is going to equal the integral from a minus 1 to a, to 1. A minus 1 to 1 dy. The integral of dy is still y from a minus 1 to 1. First we plug in the upper limit, we get 1 minus. We plug in the lower limit, we get a minus 1. 1, take away a negative 1 is 2. And don't forget to take away the a. So you get 2 minus, that is 1 take away a minus 1 is 2 minus a. Now, let's see where I can write it. So I'm going to write it right here on the bottom. We wanted to know what f sub x plus y of a equals. Well, it's a piecewise function. Sometimes we got a. Sometimes we got 2 minus a's. And other times, if there are other times, we got 0. Well, when did we get a? When did we get a? A is between 0 and 1. When did we get 2 minus a? When a was between 1 and 2. And those were the only values that really a gave us. We got 0 otherwise. I mean, think about it. If x and y are both between 0 and 1, so we talked about from 0 to 1, we talked about from 1 to 2. Can x plus y be less than 0? No. If you're thinking of a number between 0 and 1, 1 to be called an x value, and you pick a y value between 0 and 1, if you add them up, you'll never get less than 0. Nor, if you pick an x value between 0 and 1, a y value between 0 and 1, and you add up these two values, you'll never get bigger than 2. That is, the PDF is 0 otherwise. And here is your answer. Here is your nice little answer. Now, suppose that x and y are still independent, but they're Poisson random variables. They are Poisson random variables. Suppose x and y are independent Poisson random variables, and once we're Poisson, we have to talk about the parameter, and we should write down the first word I said. It didn't come out the first time. With respective parameters lambda 1 and lambda 2. Since I wrote x first, that's the respective parameter. I wrote y second, that's the parameter of y sub 2. And of course, we want to find the distribution of x plus y. Okay, so what is the probability that x plus y equals some value? Equals n. Well, there are lots of ways where it can equal 1, x and y. We can have 0 and n minus 0, which is n. We can have x being 1 and y being n minus 1, x being 2 and minus 2. We can have all the way down to we can have x being n minus 1. Let y be 1, that'll add up to n. Or x can be n and y can be 0. You have lots of ways. So, this here is equal to the probability that x is 0 and y is n, plus the probability that x is 1 and y is n minus 1, plus the probability x is 2 and y is n minus 2. That is, it's going to be the summation as k goes from 0 to n of the probability that x is equal to k and y will be the balance, n minus k. The sum is still k. So first, k is 0 and y is n. That's that one. Then k is 1. That is, x is 1 and y is n minus 1. That's that one. And eventually, k will be n. N minus n is 0. So x will be n and y will be 0. The very last one. So this is working like a charm. Okay, but these are independent. X and y are independent. So this piece, which has nothing to do with the summation, there's my summation. And then I write down this piece. Well, the probability that x is k and y equals n minus k, since they're independent, is the probability that x is k times the probability that y is n minus k. Okay. And this equals the summation as k goes from 0 to n of this times that. Well, this, the probability that x is k, is nothing more than, since it's Poisson, it's e to the negative lambda 1 times lambda 1 to the k all over k factorial times the probability that y equals n minus k, which is e to the negative lambda 2 times lambda sub 2 of that number, n minus k, divided by that number, factorial. Okay, this is equal to the summation as k goes from 0 to n. I'm going to multiply this times that. And since the bases are the same, I can just add the powers. You get negative lambda 1 plus lambda sub 2 times this, times that, times lambda 1 to the n, lambda 2 to the n minus k, over k factorial. I use the definition of the Poisson distribution, and I use the fact that e to the negative, when I multiply these two, since the bases are the same, I keep the base, I add the exponents. Okay. Now, there's my summation as k goes from 0 to n, 0 to n. Now, this factor has no k's in it. I can factor it out in front. E to the negative lambda 1 plus lambda 2 times lambda 1 to the n times lambda 2 to the n minus k all over k factorial times n minus k factorial. if I put n factorial there, I'm going to counter it by putting n factorial in front. So now I have e to the negative lambda 1 plus lambda 2 all over n factorial, the summation as k goes from 0 to n. It's k. But this piece right here, I'm going to talk about it right there. That's just n choose k. Remember, n choose k is this number factorial. In the bottom, we put that number factorial. And also in the bottom, we put the difference, n minus k factorial. But that's exactly what I have. So I can choose n choose k. That's n choose k. We come to the top. And I have what's in front, e to the negative lambda 1 plus lambda 2 over the n factorial times this summation. But this summation is nothing more than lambda 1 plus lambda 2 to the n. Remember, a plus b to the n is the summation as k goes from 0 to n of a to the k times b to the n minus k, b to the n minus k, and I forgot to put in our n choose k first. And I could have written it first. But that's exactly what I have down here, except that's lambda 1 now, and that's lambda 2. Lambda 1, lambda 2. Okay, so just comment on what we have. This is the probability that x plus y equals n. There it is. That's the probability that x plus y equals n. Find the distribution of x plus y. We did. Suppose that x and y are also binomial. Suppose that are also binomial. So once you get these formulas down and either derive them for a test or memorize them for a test, you just plug your numbers in if you're given a regular problem. For example, we just learned that for Poisson, the probability that x plus y equals n is e to the negative lambda 1 plus lambda 2 all over n factorial times lambda 1 plus lambda 2 to the n. If you were told that x's are binomial, if you were told that x and y are independent Poisson distributions with lambda 1, with x having a parameter 3 and y has a parameter of 2 and n equals 4. That is, they want to know what's the probability. What is the probability that x plus y is equal to 4? Well, it's e to the negative lambda 1 plus lambda 2 all over n factorial times lambda 1 plus lambda 2 to the 4th. It's e to the negative 5 times 5 to the 4th. 5, 5, 5, 5. 25 times 25, you really should know, is 625 divided by 4 factorial, which I think is 24. If you like, you can write 625 over 24 times e to the 5th. Once you have the formula, you just plug in the lambda 1s, the lambda 2, and the n. And on an exam, to save time, you really should know that distribution. Okay. Let x and y, as promised, be independent binomial random variables with respective parameters NP and MP. Okay, calculate the distribution of x plus y. Calculate the distribution of x plus y. So in other words, they're asking us, what is the probability that x plus y equals some number? Call it n. So like before, it's the summation of the probability that x is I, and y is everything except what x is, and I goes from 1 to n, 0 to n. Why? Because x starts at 0. X can be 0 and y can be n, or x can be n and y would be 0. But since they're independent, this is the summation as I goes from 0 to n of the probability that x is I times the probability that y is n minus I. There is one slight thing I want to change. Since the parameter has n already in it, how about instead of n, we just put k? It's the probability that the sum of x plus y is k. So n in this last line, it just becomes k. Not a big deal. N is now k. Let everyone know, and it's now going to be called k. Y is equal to k minus I. Okay. Okay. Now, one last thing. X, we are going to do n experiments. So the largest x can be is n. And since we're calling it I, goes from 0 to n. We're adding up from 0 to n. We're adding up from 0 to n. Now that n really is that n. It wasn't that n. It wasn't that n. Okay. That is what the sum adds up to doesn't necessarily have to be n. It can be more than n. Well, actually, that's not true. But it doesn't have to be n. Okay. So this is equal to the summation as I goes from 0 to n of this. The probability that x equals I. Well, there's n experiments, and you want to pick exactly I of them. That's the probability success, and you want I successes. And failures, which is Q, you want n minus I of them to be failures. N minus I times the probability that y equals k minus I. Well, there are m experiments. And you want to choose k minus I to be successes. So probability per success, you want k minus I. The probability of failure, you want the balance, m minus k minus I, which is m minus k plus I. And R choose S than R. If you only have 9 to choose from, you can't choose 10. And that might be possible. That might be possible in this case. It might be possible in that case because if m is 7, but n is 13. So you can have the sum x plus y being 15. You can have it being, say, 15. So m is 7, and if I is 0, k is, I said it, but I think I forgot. Oh, k is 10. K is 10. Okay? You can have 7 choose 10 minus I for all i's. When I is 0, you're going to have 7 choose 10, which makes no sense. When I is 1, you'll have 7 choose 9 minus 1, which makes no sense. Only when I is 3 and above, 10 minus 3 is 7. This makes sense. 1 less, if I is 1 more, you'll have 6. If I is 1 more, you'll have 5. These all make sense. So you really need to make that statement. It's very important. Now, what exactly is going on here? Well, you can't have every combination. In other words, if k is 10, and n is 13, and p is 7, you can't have 13, x is 13 successes, and y is negative 3. You can't have 12 and negative 2. They add up to 10. You can't have these. You can't have x being 11 and y being negative 1. And I meant to say m is 7. Okay, you can't have that. You can have 10 and 0. You can have 9 and 1. You can have 8 and 2. You can have 0 and 10, or can you? Okay. And so on. You can have 3 and 7. That's okay. But you can't have 2 and 8. The reason you can't have 2 and 8 is you can't have y having 8 successes. There's only 7 trials. So in those cases, we will say that we'll say that this is 0. Or possibly this one will be 0. Well, when you multiply this times this times this times this times this times this, and one of these are 0, say this is 0, then the whole probability will be 0. And after all, the probability that x is 2 and y is 8 is 0. It can't happen. The probability that you have 13 successes for x and negative 3 successes for y, that's 0. So you need to make that statement, otherwise you wouldn't know how to compute it. How do you compute 7 choose 11? They told me it's 0. Okay, so let's just do a little bit more algebra work and we'll be done. This is equal to the summation as I goes from 0 to n. We have n choose I times, we have this one, m choose k minus I. So we did those two. P to the I times p to the k minus I. Well, the bases are the same, add the powers. If you have k and then you take away I, but then you add back the I, you just have k. And q, you have n minus I, and you're adding m minus k plus I. The minus I plus I cancels, and you're left with m plus m minus k. N plus m minus k. Okay. And anything that doesn't have i's in it can factor out in front, as long as they're factors. Everything's being multiplied. So the p to the k, the q to the m minus n minus k times the summation of n choose I times m choose k minus I. Okay. This is equal to the stuff in front, p to the k, q to the m plus n minus k, times that summation, times this summation, or anything that equals that summation. I'm going to write down an identity that we should know. Okay. The summation of n choose I times the summation of m choose k minus I. This is nothing more than the number of ways of choosing, should be k objects from, not from n plus m objects. How many ways can you choose k objects from n plus 1 object? Well, but basically partition the n plus n objects into n objects and m objects. Well, first you can choose 0 from n, from the n, and k from the m objects. So this here is equal to n choose 0 times m choose k. Plus, well, now I could have chose 1 from n and k minus 1 from the m. Plus, n choose 1 times m choose k minus 1. Or, that means plus, I could have chosen 2 from the n and k minus 2 from the m. Plus n choose 2 times m choose k minus 2. And I could have gone on until eventually I choose all n from the n objects and 0 from the m. M choose n times m choose 0. But that is exactly what this says. That's exactly what that says, which is exactly what it says on the bottom. That is, what's to the left and on the bottom is nothing more than m plus m choose k. And this is what the probability that for x plus y equaling k should. You put k there, and then for the other power, you put this minus that. That's how you could remember. And again, it's just plug in. If you're given what n, m, and p are, this is a snap. This is a snap. If you're given what n, m, and p are, there's no problem here. But notice that the probability of success for x and y were the same. Suppose that x is parameter 7.1, n and p, and y is 3, also 0.1, so that's m, and that's p, and k is 2. Okay, that is, what is the probability that x plus y equals 2? Well, it's right here on the bottom. It's going to be p, which is 0.1, to the k is 2, times q, which is 1 minus p. 1 minus 0.1 is 0.9, and it's m plus n. 3 plus 7 is 10, minus k minus 2 is 8, times n plus m. 7 plus 3 is 10. Choose k. There is your answer. Okay, you just plug in. But you just have to know this formula on the bottom. You just have to know it. Or, and this takes up a lot of time, or you have to derive it on an exam. Okay, that completes the section on sum of independent random variables.